Calculate current in 15 ohm resistance for the network shown below using Thevenin's theorem. In this case, we want to use the Thevenin's theorem, and we are interested in the calculation of the current in 15 ohm resistance. I will use the steps. What is the difference in this case? In this case, only difference is that we have this current or this source, which is voltage source, which is dependent voltage source. That's it. Now try to understand the procedure. First, remove the load resistance and redraw the same circuit. Removing load resistance and redrawing same circuit. We get. Just we are removing this load resistance and redrawing the same circuit. Now in this case, how will be the figure? Now look at. This is the resistance. This is the dependent source. Here is one source, resistance. This is another source. I will remove this load resistance. Is it right? Then it will be the 4 ohm. This will be the 3 ohm, and this is B point. This is A point. This is 2 ohm. It is 3 ohm. This is 5 ohm. This is minus and it is plus. It is 4 ohm. This is 6 ohm. This is 20 ohm. Is it right? And what is this current? This current is given as I. Is it right? This current is given as I when this resistance is connected. But when this resistance is disconnected, it is having the different name. I will call it as I1. I will call it as I1. You can give any name. And then this voltage will become 2 into I1. Use any name, I1, IA, or whatever. Is it right? Now, in this case, we are interested in the calculation of this voltage. Yes, we have to calculate this voltage plus this voltage plus this voltage. Voltage across this is 0 because current is drastic 0. Yes, we have to know this voltage, which is 2 volt. We have to calculate current in this branch, that is value of current I1, to calculate voltage across this 5 ohm resistance. That's why what I will do, I will assume this current as the same as this branch current because एक ही branch है, एक ही loop है. That's why the same current I will assume it as I1, and we will apply the KVL to this loop. This is plus, this is minus, this is positive, negative. This is already given its polarity. This will be the plus and minus because this direction is downward. This is plus and minus. Now apply the KVL to this loop and prepare its equation. Is it right? Now what I will do? I will write here applying KVL. Applying KVL to above loop, we get. Apply the KVL, that is Kirchhoff's voltage law, to this loop and prepare its equation. If we are traveling from this point into the loop in the clockwise direction, we are traveling in clockwise direction, minus to plus, which is plus, its voltage is 20. Then positive to negative, which is minus, 6 into I1 is this potential. Then negative to positive, which is plus, 2 into I1 is the voltage of this source, which is dependent. Then positive to negative, which is minus, 5 into I1 is this current. Then positive to negative, which is minus 4 into I1, which is equal to 0. This is the application of the KVL. If we know this equation, let's simplify this equation. This is 6 plus 4, which is 10. Is it right? 10. This is, I guess, it is a plus to I1. This is minus. Means it is 10 and 3, 13. That is, I guess, it is minus 30 I1, which is equal to minus 20. This is right. Or indirectly, this I1 is equal to, this is 20 divided by 13, I guess. Calculate its value. Check these values. How much is the answer? All of you, check the values also. Yes, anyone?
1.5.
Yes,
53.
1.53 amperes is the I1, this current. If we know that current, then we can find out its value of the VTH, which is equal modulus value. Find out the VTH, which is Thevenin's equivalent voltage. Is it right? If we are trying to find out the value of VTH, we will travel from the B towards A. This is positive terminal, this is negative. We will travel from the B towards A, this potential, which is 0. Then we are traveling upward, negative to positive, which is a plus. Its resistance is a 5, its current is I1, which is 1.53. Then we are traveling towards A, positive to negative, which is -2. This is the value of VTH, which is equal to, how much is this value? Yes, anyone? How much?
5.65.
5.65 ओम. ये -2 को सब्सट्रैक्ट करके आ रहा है इतना वैल्यू.
हाँ सर.
Yeah. If we know the value of VTH, then we can find out the value of RTH. But be careful here. In this case, when we have the dependent source, procedure is little different. Procedure is little different. That I will discuss. Look at carefully. What we will do in the previous cases, when we have only the independent sources, जब भी हमारे पास independent sources है, just like voltage source and current source and so on. In those cases, how we are doing? For the calculation of RTH, we are removing this resistance and all sources are replaced by the respective resistance. But we don't know the internal resistance of this dependent source. We don't know the internal resistance of dependent source. That's why it cannot be replaced by 0 or it cannot be replaced by the infinite. We have to use the different procedure. How is the procedure? Now look at carefully. In this case, RTH is equal to resistance between the points A and B. This point resistance is equal to VOC divided by ISC. Try to understand this. ये formula हमें use करना पड़ेगा. Now we have to use this formula for the calculation of RTH whenever your circuit consists of dependent source. It may be the current source or it may be the voltage source. Means whenever we have the dependent source in the circuit, and by using the Thevenin's theorem for calculating the RTH, we have to use this formula VOC upon ISC. What is the VOC? VOC is the open circuit voltage, which is same as Thevenin's voltage, because Thevenin's voltage is also calculated at the output terminals when the load resistance is removed, and that voltage is generally known as the VOC. Is it right? Now what is the ISC? For the calculation of ISC, we have to remove this load resistance and we have to short these output terminals, and whatever the circuit we will get, in that case we will use any method and we will calculate current in the output terminals. That value is the ISC. Is it right? And by using the VOC and ISC, we have to find out the RTH. Now I will use. For calculation of RTH, when we have dependent sources, we have to use following formula. What is the formula? RTH is equal to VOC upon ISC, where VOC is the open circuit voltage, which is same as VTH. and ISC is short circuit current. That is nothing but current calculated by short circuiting the output terminals when load resistance is removed. How will be the circuit for the calculation of this RTH? Means we are interested in VOC and ISC. Already we have calculated VOC. Now we are interested in the ISC. For the calculation of ISC, how will be the case? Or how will be the circuit? It will be something like this. The circuit is the same. This right. Thus, only difference is that this is A point. There is the resistance. And again, this is also resistance. This is B point. It is 12 volt. This is right. This is 5 ohm. This is 3 ohm. Now short circuit this and calculate its current in the short circuit, which is ISC. That's it. This ISC. This is minus, this is plus. This is 5. It is 4 ohm. This is 20 volt. And this value is the 6 ohm. Now, this current is the I1 in the previous case. When it is open circuit, whenever resistance is present, I1 whenever it is open circuit, I will call it as I2 whenever it is short circuit. Because this circuit is different, this circuit is different. Even it is looking to be similar, but it is open circuit, it is short circuit. That's why this current is different than this particular current. It is I2, then this value will become 2I2. Is it right? Now our aim is the calculation of current in the short circuit. Now use any method. You can use, this is loop 1, this is loop 2, mesh analysis. Or this is one node, this is other node, this is branch 1, branch 2, branch 3. You can use that approach also, that is nodal analysis. Now here, already I have taken mesh analysis kind of the approach here. Here, I will use the nodal analysis method or any method. In this case, if we are using the nodal analysis method, I will assume this node as X and its potential is Vx. This is ground node, its potential is 0 volt. You can use any method. मैं यहाँ पे nodal analysis use कर रहा हूँ. आप कोई भी method use कर सकते हैं. This is I2. This current already we have named it as ISC. That is short circuit current. This is I2. And this branch current, this complete branch current, I will name it as IA because already I1 का नाम हमने पहले केस में use किया है. That's why I'm using this current as I1. This is I2 and this current is ISC. Now apply the KCL at node X. I will write applying KCL at node X. If we are applying the KCL at node X, how is the equation? Incoming current is equal to outgoing current. What is the incoming current? IA is equal to outgoing current, that is I2 plus ISC. Is it right? IA is equal to I2 plus ISC. Now simplify this equation and find out its next equation. Now look at it carefully. How I will use this approach. Now here in this case, I will prepare the values. Now look at carefully. This values. This IA is the current in this branch. How much is the value of IA? This IA is equal to, how much is this value? This is 0 plus 20 plus 2I2 minus Vx divided by resistance. Means it is 20 plus 2I2 minus Vx divided by resistance of this complete branch, which is 6 plus 4, which is 10, which is equal to. Are you getting me? How I am calculating the value of IA? This part 0 plus 20, negative to positive plus, its value is 2I2, that is plus 2I2 minus this potential, which is Vx divided by resistance of this complete branch, which is 10. 6 plus 4, 10. I2 is a current in this vertical branch. How much is its value? Its value is Vx divided by 5. Because this potential minus this potential divided by 5. Plus ISC is a current in this branch. How much is this value? This is Vx. This is Vx. Positive to negative we are traveling means minus. How much is that voltage? I guess it is 2 volt. Is it right? This is 2 volt, not the 12. This is 2 volt. Is it right? Divided by resistance of this complete path. Resistance of this complete path is the 3 ohm. Is it right? Now simplify this equation. If we are simplifying this equation, it is 20 divided by 10 plus it is 2 divided by 10 into it is I2 minus Vx divided by 10, which is equal to Vx divided by 5 plus it is Vx divided by 3 minus it is 2 divided by 3 is the value. If we are simplifying this complete equation, how will be its simplification? Yeah, it is something like this. If you are shifting this Vx to the next side, this Vx to next side we shift करते हैं. As well as I will shift this I2 also next side and I will take it as common. Vx. Then it is 1 upon 10 plus it is 1 upon 5 plus it is 1 upon 3. This value I am shifting on the next side. It will become minus 2 by 10. This is 2 by 10 into I2, which is equal to this constant I am shifting on the left hand side. That will become plus, that is 20 divided by 10 plus 2 divided by 3. Find out this equation. Vx and I2. Yes. Anyone? How much is this value of this bracket? This value and this value. I'm interested in that. Yes. Who is ready with the answer? Shailesh. Screen minimize it. Yes. Ruchira.
0.633 Vx.
0.633 Vx. Yes. Minus
0.2 I2.
0.2 I2.
Equal to 2.66.
It is 2.66. This is the equation number, I guess. How much is the equation? I guess 1. First equation. Now here we have one equation and two unknowns. What are the unknowns we have? One unknown is I2, another is Vx. Which anyhow we have to prepare another equation. Now I will come back to here. This figure. I will come back to this figure. Now already we have calculated equation for I2. What is that equation? I will show here. Already we have calculated the equation for I2, which is Vx divided by 5. This is I2 is equal to this I2. Because we have to prepare another equation. What is the next equation? Next equation will be equal to this I2 is equal to Vx upon 5. This is Vx upon 5 and we can simplify that equation. We know I2 is equal to Vx upon how much? How much is the value? Vx upon 5, I guess. Vx upon 5. Is it right? Yes. In this case, if we are simplifying this equation, this will be 5I2 is equal to Vx or Vx minus 5I2, which is equal to 0. This is equation number 2. Solve this equation 1 and 2 and find out the value of potential Vx and I2. And from this Vx and I2, we are interested in the calculation of ISC, that is short circuit current. We are interested in the calculation of the ISC, which is the short circuit current. How much is the value of Vx and I2? Anyone? Yes. Saurabh, Shivani, then Tejaswini, Ruchira, Kiran, Yes.
Sir,
Yes, Rishikesh. I'm not able to hear you clearly. Repeat once again. Repeat once again.
sir,
Rishikesh.
value of Vx is 4.48
4.48.
and I2 0.89.
0.89.
Yes.
Check it out. Ruchira. Correct? Saurabh.
Correct.
Okay. Here in this case, if we know the value of Vx and I2, in what value we are interested in, I will come back to this figure. We are interested in the calculation of ISC. And this ISC, its equation for this ISC already we have prepared. What is the equation for ISC? This equation. ISC is equal to Vx minus 2 divided by 3. This is Vx minus 2 divided by 3 is that value. Is it right? Therefore, this ISC is equal to, we are interested in the ISC. This ISC is equal to, how much is the ISC? Vx minus 2 divided by 3. This value is Vx minus 2 divided by 3. Which is equal to, how much is the Vx? 4.48. This is 4.48 minus 2 divided by 3. Find out its value of the ISC. Yes. Anyone? Yes, Ruchira. Unmute yourself.
0.82.
This is 0.82. Amperes is the ISC. Avinash, unmute yourself and check the answer. Avinash. Yes, unmute.
Correct, sir.
Correct. So here in this case, now we know the values. We know the values of ISC. Now I will find out RTH. Is it right? Because whenever we have the dependent source, in this case, this RTH is equal to, now it is VOC upon ISC, which is equal to, how much is the VOC? That is Thevenin's equivalent voltage, which is 5.65. This value is 5.65 divided by, it is 0.82 is the value of RTH. How much is the RTH now? Yes, Saurabh.
6.89.
6.89 ohm is the value of RTH. Now, if we know the VTH, yes, Akash, correct? Yes. Now here in this case, if we know the value of VTH and RTH, if we know the value of VTH and RTH, then we can calculate. When we know the VTH and RTH, we can find out VTH and RTH. VTH and RTH. The complicated network is replaced by Thevenin's equivalent network. How is the figure now? In this case, this will be the final figure. This is RTH. How much? It is 6.89 ohm. How much is the VTH? 5.65. This is 5.65 ohm. And reconnect the load resistance which is removed in the first step. How much is the load resistance? We are interested in the calculation of current in 50 ohm resistance. This our load resistance is the 15 which we have removed in the first step. This is 50 ohm. Now calculate its current, that is load current in this case. Now this IL is equal to 5.65 divided by, this is 6.89 plus 15. Work out this calculation and find out its value of the load current. Yes, Akash.
Sir, 0.25.
It is 0.25 amperes. 0.25 amperes. Yes. Anyone again? 0.25 amperes is that value.
Correct, sir.
Yeah, correct. Yes. Just a minute. I will start.